Trees grow in very specific places, and we call these places their habitat, and those habitats are within the range of individual trees, the areas, the distance covered by those trees. And then those trees, those habitats overlap, and those trees form community. And so we're going to be talking about habitat, range, and communities of trees. Habitat. Each species has a specially adapted to a particular set of growing conditions. When those conditions are met, the tree will successfully thrive and reproduce in that location. These are some of the factors that contribute to make up a habitat. Climate, soils, physiography, which is elevation, slope, soil wetness, aspect, and then other local biota, other living things. The competition among those living things also will indicate whether or not a particular plant or other living thing can survive on that location. We'll start off by talking about climate. And I'm sure you've all heard the word climate, and I just want to make sure everyone's on the same page when we talk about climate versus weather. Climate is the broad, larger scale discussion about the general conditions of a particular area. This is regional or multi-state. It's the product of the interaction between solar radiation, the sun, the atmosphere, and the land and water masses of the earth. This image is depicting some climatic zones of the continental United States. These zones are interpreted differently by different people looking at different criteria. But in this model, where we are in central New York, is considered humid continental with a cool summer, and just a little bit further south is humid continental with a warm summer. This is another climate model. We are in the Northeast in this model with pockets of New York considered to be the North, which is the same as the upper Midwest and the Pacific Northwest with the dark green. And so looking at different conditions or different ranges, we can get these different climate zones. One model that's commonly used when we talk about plants is the hardiness zone map. And this really refers to cold temperatures and the coldest temperatures by grouping across the country. Typically, these are done in 5 or 10 degree chunks. And you can see the blue part of New York State, that is considered zone 5. And additionally, we split that into zone 5A and 5B, with B being colder than A. And the major color changes in this map are 10 degrees. And so we know that where we are, we have cold winters, and zone 5 can have negative 20-degree winters. And it really only takes one day at negative 20. And when you look at cold temperatures, that's the minimum threshold where certain plants can survive. And so some plants can tolerate negative 20, some can only handle negative 15, and therefore will not do well on those really cold winter days. And we often see plant mortality when they experience days beyond their hardiness zone. The Adirondacks, that's kind of a purpley color, could be negative 30, and that kind of pink in the middle, potentially negative 40. Pretty darn cold. Only certain plants will live under those conditions. The hardiness zone, again, for our area is zone 5. Though just to be sure, I often tell people to buy plants that are zone 4 tolerant, because we do have negative 20-degree winter days or winter nights every so often. But every so often we have something that's like negative 22 or negative 24. And then those plants that are just not hardy don't make it. The next element is soils. Soils are critical. You may not really think about soils too much, You should have taken our soils class. If you haven't taken it yet, you will take it soon. But really keep in mind that soils are vastly important. Soils do things like provide moisture, nutrients that our trees and other plants need for growth. They hold mass in the ground. And the interplay of drainage and nutrient availability, pH, texture, density of the soil really dictate what plants are going to grow and do well in this land. Soil also contains microorganisms that are both beneficial or potentially harmful to the tree, depending on the situation. So soils are critical. pH, nutrient availability, and water holding capacity are the main things that dictate which plants can grow under this soil. We're just covering a very brief piece of each of these elements just to give you a broad understanding of the kinds of things that play into habitat and range and community. So just keep that in mind as you think we're just moving through these rather quickly. This next one is physiography, and this is the lay of the land, the shape of the landscape. So elevation, slope, aspect, land shape, and land-water interface. Elevation. As elevation increases, the temperature, the average temperature, and the length of the growing season decrease, as well as soil depth. You go up a mountain, it gets colder, the growing season is shorter, and the soil gets thinner. It becomes harder to grow there. Solar radiation increases, you have less atmosphere between the top of the mountain and the top of the atmosphere. So there's more solar rays, more damaging rays. There are certain categories of plants that have adapted to grow in these places, and we refer to them as alpine species. A lot of the alpine species are small, slow-growing, very, very durable plants. But we do have alpine trees. They don't necessarily grow all the way to the top of the mountains, but they grow up towards the tree line. I'm sure you've heard the phrase tree line. And as they grow, they're typically shorter and stunted and can really capitalize on this niche market where other trees cannot. Aspect. This is the direction that the slope is facing. If you stand on a hill and face away from the hill, the direction you are facing is the aspect. And this is important because southern and western slopes are warmer and drier. The sun is always in the southern sky, and so the slopes that face south get more sunlight. The northern side of that hill, that mountain, and the eastern sides are cooler and moister. So the northern slopes, especially because the sun is always in the south, but the eastern slopes, the morning sun is not as hot. And so they typically are cooler than western slopes. And particular plants have evolved to grow in warmer places and cooler places. And you've probably had the experience of walking around a hillside and having certain trees on one side of the hill and other trees on the other, on the southern side. And so like on the north, that's where we typically find things like hemlock. And on the southern, warmer side, we might find oaks on the same mountain. Soil moisture. The amount of moisture in soil, the amount of water available to the plants is important, both for the amount of water that the plants need to take up, as well as what they're able to tolerate to live in. And specific trees have adapted to these different soil moisture regimes. We have wet species, dry species, and mesic species. Wet is also referred to as hydric. Mesic is like middle, not too wet, not too dry, usually what we call well-drained soils. And then dry sites are also xeric. And some of our wet species are willows, and really anything that's got swamp in front of its name. There's lots of plants actually that are well adapted to live in wet areas. And some of these wet areas might be swamps, but they might also be bottomland areas. And bottomlands are floodplains from rivers where we see seasonal spring floods that often drop a lot of silt, and they can handle these temporary floods, whereas other plants really are swamp species that can handle year-round water. Mesic sites, these well-drained areas, not too wet, not too dry, middle of the road, are plants like sugar maple, red oak, white ash. They prefer mesic sites. Red oak can be a little bit wet and a little bit dry, but really they do best on the mesic soils. Dry areas, the really well-drained locations or very thin soils, you might see things like pitch pine or junipers or eastern red cedar, where there's not a lot of soil moisture for them to grow. A couple terms I want you to be familiar with. Obligate and facultative. Obligate means it has to. Facultative means usually or sometimes does. So an obligate wetland plant pretty much always is going to occur in wetlands. And we talked a little bit about this at the horse arena when we looked at some of the plants that grow in the swamp or that grow on acidic soils. And so we use the word obligate. But when they are obligate, they always grow in wetlands. Obligate wetland plants always grow in wetlands. And we can use their presence to determine whether or not it is a wetland. Facultative wetland plants usually grow in wetlands, but not always. And so it's not surprising to see them there, but they're not going to determine whether or not that site is considered a wetland. Local biota, the living things in that location. The sum of all living organisms that inhabit an area and exert a positive or negative influence on the suitability of a habitat for a particular species of tree. Remember, this is an ecosystem. There are other living things there. How do they interact? When we talk about ecosystems, we'll talk about them in the living things in different categories of life. But we can also talk about them by the roles that they play. As we're concerned with trees, we might be looking at competitors, herbivores, and pollinators. We'll also have incidental wildlife. Competitors are going to be the other plants that are directly competing with our desired trees, or any tree really, for nutrients, sunlight, and water. They can shade each other out. Their roots can invade each other's space. They can pull water and nutrients away from each other. Herbivores, these are the things that eat the leaves or eat the twigs, that eat the trees. How many of them are there? What kinds are they? What kinds of damage are they doing? We have an overpopulation of deer. We have an outbreak of a particular caterpillar that's going to eat all the leaves. What are they? How often are they there? What kind of impacts do they have? Pollinators. Some of our trees are pollinated by insects or birds or bats. Not our trees, but other people's trees. So what are the pollinators that our trees need? Many trees are pollinated by wind, so they don't need pollinators. But some trees do require pollinators. And so if they're not around, that tree probably won't survive. That population of trees won't survive. Then we have incidental wildlife. There are other things that live there that can affect the tree. We might talk about woodpeckers or porcupines or animals that are going to affect the tree directly, but may not necessarily affect the population. And so how do these animals or wildlife come into play? Getting back to the concept of competition, I want to spend a moment and talk about shade tolerance. Shade tolerance. When we use the phrase shade tolerance, it used to really mean how much shade an individual tree could handle and still grow well. Since then, we've kind of dropped the shade part and we really talk about tolerance. And it's how much competition a tree can handle. Shade is part of the competition equation, but so are nutrients and water. And so certain trees can handle a lot of competition. They can handle a lot of shade. And you'll still hear myself and other people refer to it as shade tolerance. But so certain trees can handle a lot of density. They can have other trees over top of them. There can be a lot of them close together, and they will be able to reproduce and grow. Sugar maple is a really great example of this. Hemlock, American beech. We refer to these trees as also climax species when we talk about succession. They can reproduce in a closed canopy. They don't need that much light. Other species can't survive in a closed canopy situation. They need a lot of sun. And black cherry, aspen, paper birch, these are all trees that need full sun to reproduce and thrive. We refer to trees like the black cherry and paper birch as shade intolerant. They can't handle shade. And even something like aspen will start to shade itself out, the individual tree. And once it gets too much shade on itself, it starts to die off. Sugar maple is shade tolerant. It can handle a lot of shade. And then we have trees in the middle. Most of our oaks are what we'd call intermediate. Red maple is kind of intermediate to shade tolerant. And so different trees can handle different amounts of sunlight for growth and for reproduction. And as I go through the semester and we talk about different trees, I will tell you the shade tolerance of most of the trees that we cover. Take the details of what we just talked about with climate and soils especially. And where these things come together, that is really where the trees have decided that they want to grow. And so we typically know that sugar maple is a northeastern tree and it likes mesic soils. And so we can extrapolate that a little bit, and we would call that its range. And we have documented ranges for most of the trees and shrubs that we'll be covering in this class. And the range has been mapped often or interpreted based on historic locations of the right kind of places. And most of the range maps that we use were created based on where the tree grew, or still does grow, at the time of colonization. And a lot of the maps that we use come from this textbook that's listed here, Silvics of North America, and there's a link there, and I'll put the link in the Blackboard page so you can actually click on it, but you can do a Google search for it. And the manual, the Silvics of North America manual, is a really great reference for all things about mostly commercial trees, so forest trees that have some kind of commercial value. But we have some wonderful maps that kind of document where these trees used to grow and still grow. Natural ranges, where they are growing now, these natural ranges are shifting as conditions change on the ground. And climate change is one of the big things that alters ranges, as well as human-aided planting. And throughout the semester, we'll cover a couple that have already been affected by both of these things. So here are two range maps. The first range map on the left is Quaking Aspen, and you'll note that it grows all around New York State in the northeast and the Lake States across Canada, the Pacific Northwest. This is a tree that requires colder temperatures, full sun. You'll also notice that it drops down into the southern part of the U.S. You see it in the Southwest in California. If we know that this is a cold species, it's in the Southeast, the Southwest. Now, you probably can tell based on where it is that living in high elevations, the mountains. And so those same high elevations, those same conditions, similar to the conditions that it lives in the northeast, the Lake States, and in Canada. So those same community habitat requirements are the same or similar enough in New York as in Mexico. On the right, we have baldcypress, which is a very southern U.S. tree. It lives in coastal areas and swamps, conifer, and you can see it has a very limited range compared to the aspen, which lives all across from one coast to the other coast of North America. Bald cypress is really limited to the southeast, up some of the to the interior just a little bit in the river valley. So the requirements of these two trees are very different. Bald cypress is a warm species, also likes wet areas. Bald cypress can be planted and does well in New York State as an ornamental tree. We're not going to have populations of bald cypress, so while it can survive in New York, it's not going to thrive. It's not going to reproduce. So the range we're looking at here is where this tree evolved over thousands of years to be able to thrive and reproduce. Forest communities. These are terms mostly, or regions, of similar plant life. And we refer to them as forest communities because the forest trees are the dominant species, the dominant tree that make up the overstory. And we have labeled these different communities based on kind of the average or the predicted types of plants that we expect to see. And so I know that I can walk out the door at Morrisville into our Maple Beech birch, which we also call northern hardwoods, into our Maple Beech birch forest, and I have a reasonable expectation of what to see. I'm going to see sugar maple, red maple, hemlock, American beech, white ash, black cherry, white pine. So this is a group of trees that has relatively similar requirements, and they all typically grow together. And I can also generally say that while that might be the mature forest, if that mature forest gets wiped out, I can predict more or less the plants that are going to come in and what kind of order they're going to come in and what the ultimate look of the forest is going to be like. So we have these different named communities, and they overlap and they do change a little bit depending on conditions on the ground. But it's a way to describe groups of forest types. This is our forest cover map, forest cover type map, with these different forest communities. And these forest types on the left-hand side there are created by the U.S. Forest Service. And we are in eastern forests. And so you might notice that there's western forests and some of the colors look similar. And there might even be some names that are similar. So like we have in the east, the yellow one is spruce fir. And in the west, they have one that's fir spruce. They are very different. They are made up of very different types of spruce and fir, not the same. And so just keep that in mind. But so we're going to look, of course, at the east here. And in the north, we have Maple Beech birch is that kind of medium green, and some of the darker greens are oak pine. Like a brighter green is oak hickory. We have both of those in New York State. Spruce fir we have in the Adirondacks and up into New England a little bit further. We have, as you go down into the south, we pick up more pines. Longleaf slash pine, loblolly, shortleaf pine. And again, these are forest cover types defined. We use the names of the most common trees, 2 or 3 most common trees of that forest type. This is a close-up of New York State's forest cover type. And as you look at this image, you'll see it's kind of pixelated. And these are cover types that are derived from satellite images. And so we can kind of look down in and be like, okay, this particular pixel is this forest and this is that forest. And both of the forests that you see in New York State is this maple beech, and medium green. We also call it northern hardwoods. So you will see that there is mixed in the oak hickory. So it's basically saying the majority of this forest, the dominant cover types in this forest are maple beech or primarily oak hickory. And that doesn't mean that there aren't other species there. That's just the category. Maple beech birch is also going to have white pine and hemlock and oaks and elm, ash, and other things that might be labeled in these other forests, but that's just the category of forest that it is. An oak pine forest is going to be a little bit drier. You can see those further down in the cattails, the darker green, a little bit drier, a little bit warmer. Elm, ash, cottonwood, which is brown. I don't know if you can see the tiny brown pixels, but they are a more wet area. And so, spruce fir, those are colder. Those regions are colder. And so we can kind of evaluate. So we have a section based on the climate, based on hardiness, soils, the amount of sunlight. These are the types of trees that are going to grow, and we have a general idea of what that forest